Thank you very much. So I'm the one standing between you and your Aperol, I heard. I try to keep it short, but even though I'm talking about clocks, I might actually go over time. Sorry about that. Oh, that was really, really short. Yeah, I'm going to talk about clocks and about figs. And the whole thing, let me shortly introduce myself again. Well, no, actually I don't need to do that because you already heard that. I'm a time nerd, fine. I would really appreciate feedback, constructive feedback on joined in. If you have problems with joined in, feel free to contact me afterwards. I'm also co-maintaining that. Yeah, let's dive into the whole topic. Why am I talking to you about clocks? Well, because a few years ago, a bit over 3 years ago, I was sick in hospital. I had nothing to do for 2 months, and I don't recommend that. And I got an email. I'm lurking on the PHP-FIG email mailing list, and someone sent in an email there, and that was related to time zones. And yeah, I had nothing to do, so I leapt for it. But before going into more details on that, I want to talk about some best practices with you. I want to walk you through an example about best practices. We're going to touch test-driven development. We're going to touch solid principles. We're going to touch object-oriented programming. It is a thing, even though we heard this morning that some people think it's not. Well, it is. Yeah, and I'm going to show you a bit of code for that, and we're going to run through a bit of code so that you understand what I think is a good idea. For that, I've thought about a short challenge, a really minor challenge. Let's find a way to filter all items from a list that are in the future. That's easy, isn't it? You're kind of? Yeah, good. Sounds trivial, but we'll hit a lot of obstacles on the way. So this is what I thought would be a good idea to do that. So we create a filter future items class, and we inject that class into an array filter function that gets an iterable or an array of arrays, and one of these array contents is an integer that is called, or that has the key time. So we have kind of an array of things. Each of these things has an array key time, and that contains an integer. And we want to know, is that integer, which hopefully is a timestamp, is in the future or not? Sounds trivial. So let's have a look. How do we implement the filter? Well, that is pretty easy. We create the filter future items class, and then, yep, have the function valid. And this function valid checks whether the return value from the time function is smaller than this time thingy. That's it. Easy, isn't it? I wouldn't be standing here if that would be all. Have you thought about testing? How do you test that? And that's where the best practices comes in, and test-driven development. Because, to be quite honest, this clock thingy is awesome, and it helps you in testing, but you don't need it just to ship code. If your task is shipping code as fast as possible and you don't care about testing, you don't need a clock interface. You can go directly to your Aperol. But it looks like you all want code quality. Good. So is my microphone, seemingly. I have no idea why. So the challenge is that this time thingy, this time method, changes its state constantly. Well, okay. And so how do we get around that? Because if something changes state, it's not kind of a pure thing, a pure function. The best thing to test is a pure function Pure function is a function that always returns the same result when you pass in the same values. And that doesn't have any side effects. The side effects are irrelevant for us, but in our case, the problem is we can pass in the same parameters into the function, but at one point in time, we will get a different result. And that is really, really, really hard to test. So let's have a look at the code here. So this time function is probably something we do not want. So how do we change that? Well, easy thing. We just pass in the comparison value. So instead of just having a valid $item, which contains the array thingy, we also pass in the current time. And then we compare the current time to what is in this time value. Easy fix. But that is also a challenge. Why is that a challenge? Well, we have changed our function signature. We are suddenly expecting 2 values to be passed in instead of 1 value. No, that is not a good idea, because we already kind of have built some code, and that means a lot of refactoring and stuff, so we don't want that. So let's not change the function signature. What can we do instead of changing the function signature? Any ideas of solution? Okay, we use constructor injection, because we have a class, and we can just inject something into that class. So we inject this current time into the constructor, and then whenever we call valid, we do not compare it to $current time, but to $this current time. Hey, that's cool. That's quite good. Let's write a test for that. Looks a bit much, but let's go through that. So we first kind of create our items. This is our array of arrays. We need the time part here, so we ignore everything else, and we use time -1, time +1, so we have kind of a decent range. And then we create our future filter items with the current time to compare that against. And then we can assert that the first 2 should be false and the last one should be true. You with me? I see some nodding, yes. Anyone see some problems in that? Thank you very much. So the challenge is that, well, we are calling time multiple times, which kind of will result in, yes, sometimes working tests, and sometimes it will just break. And yeah, debugging that is a lot of fun. So how can we fix that? Well, okay, we just call time once. Now we have a fixed time in this $now parameter variable, and then we just subtract, add 1, whatever, and well, this is more or less the same as before. And that's about it. That works. There is still a challenge. That's not a technical challenge, that's more like a mental challenge, because so far we were using integers. An integer is an integer is an integer. We do not know whether that what we are passing in here is actually the time, or by some coincidence the amount of money that the new train line between wherever cost. It's just an integer. We do not have any type safety. So by now, modern PHP applications should use decent type system to make it sure that we are passing in a date time and that we are handling the right values, the right information here. So let's shortly check how we can do that. We use dedicated type instead of an int. What is the dedicated type for that? DateTimeImmutable. So instead of calling time, we are now using new DateTimeImmutable. We still have an integer in our definition for this array, so we need to get the timestamp from that. But the new filter future items takes $now. Make a mental note of that. And the rest stays the same. There is a slight challenge. because we now have to rewrite the filter class. Mental note, we are now not passing an integer anymore into the constructor, but a DateTimeImmutable object. So we have to replace that accordingly, and in our valid function, we just use this current time, get timestamp, instead of this current time. But that should be fairly trivial. That's it? No, it's not yet time for an apéro. Sorry about that. Because there are still some challenges. Did anyone spot the problem? We now have kind of written our function, our valid function, so that we can test that very easily. But that was what where we came from. So now we are calling our new filter future items with a new DateTimeImmutable. How do we test that? Because now we have kind of moved the instantiation of our current time up one level. How do we fix that? How do we test that? We have to move this instantiation of the current datetime up another level and another level. And yeah. We could also use time, but that wouldn't save us anything. It would kind of still be the same. We could move the instantiation up more or less indefinitely. How do we fix that? How do we do that? That we kind of instantiate something at a certain point in time during runtime. We've already heard that a few talks back, where someone was talking about factories. No, we're not going that deep. We're only using factories. That's the solution. Let's build a factory for that. Let's build a factory that just returns us the current DateTimeImmutable object. So what is a factory? Factory returns us something at runtime that we need. It instantiates something at runtime, and it gives us a pretty easy way of getting this constantly changing thing. So let's build a factory for a current datetime factory. Not much happening. That has a function get current datetime object. I do love explicit naming. No, yes, I did some Java programming, but that's not because of it. This just returns a new DateTimeImmutable object. Now we can improve this filter a bit further. Instead of injecting the current datetime, we are now injecting this current datetime factory into the constructor. And in the valid function, we just call this get current datetime object method from this factory. You're still with me? I do not see any any shaking heads. That's good. So now that we have done that, we have to, of course, change our call here. The new filter future items class is now instantiated with this current datetime factory. There's only a very small number of changes necessary to do that. To just move from the DateTimeImmutable to the DateTimeImmutable factory. That's great. So I have another challenge. But is testing really a challenge? I mean, it should be fairly easy, shouldn't it? I mean, we can create our new datetime factory instead of the new DateTimeImmutable. Then we have to kind of get the timestamp by using this get current datetime object method, and so on and so on. In the here in the actual filter future items part, no changes necessary because we already did that. But we are still kind of getting a real DateTimeImmutable object. So if we want to test something that only happens every 4 years, like during a daylight saving, sorry, during a leap year transition, then we have to wait 4 years until we can actually test that again. That kind of sucks, doesn't it? Wouldn't it be cooler to actually have the possibility to kind of say, we are testing this on the 29th of February, so just inject 29th of February in here? I mean, that shouldn't be too complicated, should it? I mean, we have this immutable factory. We can just extend that or mock that and just use mock the getCurrentDatetime object function so that it returns the 29th of February. Should work, shouldn't it? So getting a dedicated testing factory kind of thing. Oh, foo. Who spots the problem? Yes? Thank you. I made that a final class. The problem is final classes are either immutable or they require an interface. Is this factory immutable? It does not need to be, but it definitely does not have an interface. So, and yes, please, removing the final is not an option. Someone thought about that. But let's use an interface for that. So let's create a datetime factory interface that just defines this getCurrentDatetime object method. Yeah. And then go back to our current datetime factory and just add implements datetime factory interface. Do we need to do any other changes? Yes, we do need to do one other change because we don't need to change the implementation because the getCurrentDatetime factory is already there. But we have to inject that into the filter future items instance. So we need to replace the type hint of the constructor from datetime factory to datetime factory interface. That's all the change that is necessary. The calling is still the same. We are still using the current datetime factory because that now implements that interface. Everything's fine. This is kind of our production code. Everything's cool. We can just leave that for production use. In our test, we can now create our own test factory. So this test still, the beginning stays the same. We have our new DateTimeImmutable that is kind of injected in this variable $now. We have our $now getTimestamp, whatever. That's nothing new. And then we are using an anonymous class. What? Marco showed me that and I was like, wow, that's awesome. So we just create our factory now, which is a new class that extends the DateTimeImmutable interface. And we just define two functions in that, the constructor that takes a DateTimeImmutable object and our getCurrentDatetime object method that returns that datetime object. And then we create our new filter future items with that factory. And that stays the same. Nothing changes here. It's cool. And that's about it. That's it. Well. It works every time. Thank you very much. No. Well, I mean, in essence, that is the whole thing, because that is how a clock interface works. That is the implementation of a clock interface that you've just witnessed here. So let's just do a few renamings. Let's call this datetime factory interface a clock interface. Let's call this current datetime factory a system clock. And this anonymous class, let's just call, if we put that into its own class, let's call that a fixed clock. And perhaps also rename this getCurrentDatetime object into now. So why do we need the FIG? Why do we need the framework interoperability group if that is so easy? That's not even 20 lines of code to implement this whole thing. Well, the problem, the thing why we need the framework interoperability group for that is the interoperability part. Because yes, it is easy to build, but everyone builds their own implementation of that. And whenever you want to change, you want to kind of use some other library that also needs a clock, they have to implement that themselves. So in essence, your code ends up with, I don't know, 15, 20, 25 different clock implementations. That is cool, but perhaps not necessary. So who of you has heard of the FIG? Who of you knows the FIG? A few, yeah. Okay, yeah. For those that don't know the FIG, Framework Interoperability Group was founded around 2010-ish. The most important thing influenced all of our programming was in 2010, the PSR 0. PSR is the PHP standard recommendation, 0 for the, first one. Off by one error, no. Which was created in 2010. And without this PSR 0 that defined how class names can be found in a file structure, Composer would not have been possible. And without Composer, we wouldn't be creating PHP as we are doing now. So without the FIG, no PSR 0, no Composer, no modern PHP. That is why the FIG is actually still relevant. There was also like PSR 4 autoloading in 2013, replaced PSR 0 now that we had namespaces that handled a few things differently. PSR 3, a lot of you are using for logging. PSR 6 for caching is a thing. PSR 8, the huggable interface. If you don't know what that is about, feel free to come to me or Michelle later on. Yeah, how did I get involved in that? As I said, I was lurking on the mailing list. And Chris Seufert wrote a proposal like, hey, wouldn't it be cool if we would have a PSR for this clock interface thingy? At that time, there were already a lot of implementations, like 4 or 5 implementations that already had a clock interface. And each of these different implementations had their own interface, which kind of made it not interoperable. And the idea was to just combine that. As I said, I had a lot of time, and time zones were involved, and I've seen that. And I was like, that feels wrong. And I had seen a few of these implementations, and they all had kind of one function, and I was like, why do we need 5 functions for that? And especially, why do we, I mean, there is one that returns a datetime immutable and one that returns a datetime. And I still have Derek in my ears like, datetime immutable is what datetime should have been in the first place. So if you're using datetime, don't. Get rid of that, add an immutable, and you will be happy. Thank me later. So we don't need that. We don't need datetime. If you really know what you're doing, which you probably don't, then use datetime from datetime immutable. That's fine. Similarly, the datetime immutable object contains a time zone already, so we don't need a separate function to get a time zone. Why? Also, the timestamp, it's already in there. We have the getTimestamp function. We've used that already in the code example. So why? And the microtime, similar. We already have that. Well, not much left. So why not just rename this immutable to what everyone else is using in a clock interface to now? That's the main thing. That was 3 years ago. The interface itself, or the PSR itself, was published 1.5 years ago. Why 1.5 years in between? Because, hey, the discussion about this took about 2 days on the mailing list. There were a lot of different people involved. And after 2 days or something like that, we were clear, yeah, that's it. Yeah, and then people came around like, oh yeah, but we need sleep. We need a sleep function defined in that interface because for our testing things, because we have that in our code and we need to kind of shorten that in our test runs. No, you don't. I mean, yes, you might, but that is a separate interface. This interface segregation principle, an interface does one thing really good and not multiple things. And sleep is only for testing, so we don't need that in a production interface. Doesn't make any sense. It took quite some time to convince people about that. Yeah. Time zones are a thing. It's sorry about that. The main problem was like, yeah, but if we have this now function, we need to make sure that this now function only returns UTC. Why? Because this now function returns now. It returns the current time. Well, it returns a current point in time, not the current time. So whether that current point in time is, for one thing is, you can set the time zone. If you explicitly need to have your datetime immutable object that you get from your interface, if you need that in a specific time zone, make sure that it is in that specific time zone by setting it explicitly. Otherwise, you might get the right thing, you might not have fun in debugging that. And that was the wrong direction. The main question is, what is now? Now is a point in time. You can describe this point in time in UTC. You can describe that point in time in the time zone Europe-Rome. You can describe the same point in time in the time zone America-Toronto. Or in whatever, Asia-Ankara. I don't care. It is always the same point in time. If you have issues with that, feel free to come to me later. I'm not going to draw that into length. And the cool thing is with DateTimeImmutable objects, no matter what time zone they are in, you can compare them. You can create a DateTimeImmutable object with time zone X and create a new one in a separate time zone or a default time zone, and then you can just compare them. Is $A greater or smaller than $B? And it will give you true or false. No need in worrying about time zones. It's just, is this point in time earlier or later than this point in time? That's awesome. And that's why, well, that's how value objects work. You don't have to care about the internals of that unless you explicitly need to know that. If you have to know the time zone of a DateTimeImmutable object, for me, that is a code smell. Something fishy is going on there. Usually, you do not know what you do. Even I, most of the time, do not know what I do there, if I need to know that. Nevertheless, a lot of the implementations, so from an interface point of view, you do not need to know the time zone. From the implementation point of view, you can still perfectly set a certain time zone. So there are a lot of system clock implementations where you can explicitly say, I want my system clock to be in time zone X, in time zone Y, in time zone Z. No one is forbidding that. Think about it, why you need it, different story. But from the interface point of view, there is no need for that. The interface allows you to use whatever you want. If you want to have the time you get, the datetime object you get from the interface, if you want to have that in Europe-Rome, explicitly set it. So you know explicitly, yes, this is Europe-Rome. This is what I want, or whatever. So convention system clock is the production factory kind of thing, which can be time zone specific, doesn't need to be. And the frozen clock is kind of this thing that you use for testing. There are different implementations of frozen objects that return only one DateTimeImmutable or multiple in successive calls to now, whatever. And you use that like this. You inject the clock interface, not the actual implementation, into the constructor, and then you just call $this clock now to actually get the current date time object. And then you do whatever you need to do with that. And that's all there is to that clock interface. Why did it take 1.5 years? Partly because of time zone discussions, partly because, yeah, the FIG process requires certain people to actually do something at a certain point in time. And those two people that had to do something suddenly vanished. So it took quite some time to get hold of them and to restart the process kind of, and then everything kind of worked and was fine. If you have any questions, because I think we are almost running out of time and you want to get to your Aperol, ask me at the Aperol. Unless you have a question now and we have to talk about that on the online thing. Yeah, thank you very much. I do have a list of links in the slides. I will put the slides up to on Joined In later on. So please, again, I'd be happy about feedback on the talk. And now I'm done.
Thank you. Thank you. And also remember that you can rate all the talks that we had today on Joined In. So since you don't want to take any questions, I can just close the day.
Well, if you have questions, especially from the online audience, I'm happy to answer them, or at least I try to answer them.
I don't know, maybe we have time for one question. If there's one, I don't know, maybe not. Not now and not from home. Now you have a question.
Sorry, it's a very important question.
Yes.
What's the time on your shirt?
Yes. Anyone ever heard of the doomsday clock? That is the time on the doomsday clock. Like 1 minute 30 to midnight.
Okay, so I should be careful today, or what's the date
No,
for that time?
the doomsday clock is something that some nuclear physicists developed. Like they thought, like you're always talking about, it's 5 to 12, and so depending on the current political situation, they were thinking of we actually need to have a doomsday clock that shows what is the actual time, and depending on the political situation, that goes back and forth. And currently, it's 1 minute and 30 seconds before midnight, kind of before everything blows up. Local time.
I feel much better now, thanks. Yeah.
Any
Thank
other
you.
questions?
No? Okay. So another round of applause for Andreas.